Hey everyone, in this video we're going to take a look at when we're given a function that's got multiple different trig functions in it and we're asked to simplify it into a single general sine function. So you can see we're given the function here, square root of 3 cos 3x minus sine 3x. And we're trying to put it into the form of just a times sine of omega x plus phi. All right. So how do we start off with a question like this? Well, I would like to teach you a way where it doesn't rely on any sort of memorization of any sorts. So you can just remember and understand how to do it from this video and then easily remember and replicate this on a midterm or an exam where you don't have to, or you can't rely on a cheat sheet or memorizing. So let's take a look. Let's start with a times sine omega x plus some phase shift here, phi. We can see right away that omega is going to be 3, right? That should be jumping out at you right away in this question, right? You can see what's tacked on to our dependent variable. It's 3. So just by observation, 3x, all right? And sometimes the question will give it to you. If it doesn't, plug it in right away because we can tell. So we've got two unknowns that we're solving for, a and phi, right? A being our amplitude and then phi being our phase shift here. So what we're going to do is rely on a simple trig identity to remember for sine of the addition of two things, right? Well, sine of 3x plus phi, well, we could simplify that to sine 3x times cosine of phi plus sine of phi times cosine of 3x. Let's then multiply the a inside of our brackets. We've now got, and actually I'm just going to rearrange this ever so slightly because it's all multiplication here. Cos phi times sine of 3x plus a times sine phi times cosine 3x. Okay? So let's take a look here. We've got a cos phi on our as the coefficient on our sine 3x term. Let's take a look at the sine 3x term from the expression that we were given. You can see that the coefficient on this term is -1. So we have -1. We want that to be equal to a times cosine phi. And just like that, we've got equation number 1. Let's take a look at equation number 2. Okay? The coefficient on our cos 3x term is a sine phi. And from the expression, we can see that it is square root 3. So we've got now square root 3 must be equal to a times sine phi. And now, just from that one simplification of our trig of our sine of 3x plus phi, that one trig identity, we've just come up with a system of two equations and two unknowns, and that is a lot easier to work with. And suddenly it's not this gross trig question, and suddenly all we're doing is solving a system of two equations and two unknowns. So the way that I like to solve for a is squaring both of the equations and adding them together, right? And you know, there's multiple ways that you could do this. This is just the way that I like to remove one of our variables, right? So we've got -1 squared from equation 1, and we've got square root of 3 squared is equal to, and now we've got a squared times cos squared phi plus a squared times sine squared phi. We can then factor out the a squared from our right hand side, and we know that cosine squared of phi plus sine squared of phi from our Pythagorean identity is just going to be 1. And then the left hand side, well, we've got 1 plus the square root of 3, so that's 1 plus square root of 3 squared, so this will be 4. and then square rooting both sides, right? We get plus or minus 2 is going to be equal to a. Great. And there's, you can choose either value of a here and then solve for the respective phi, and that will just give you multiple solutions. So we can choose whatever we want. In this case, let's choose -2, because when I was doing my general cosine function video, we chose negative a. So let's choose, or positive a. So let's choose negative. So let's let a be equal to -2. Okay, and then to solve for phi, let's just pick one of these equations. We've got a -1 equals, -1 equals -2 times cosine of phi. And this is from equation 1. There we are. So we've then got half is equal to cosine of phi. From equation 2, let's take a look. We've got square root of 3 is equal to a sine phi. So we've got square root of 3 is equal to -2 times sine phi. Or we've got negative root 3 over 2 is equal to sine phi. So in order to solve this, we need to take a look at our cast rule. So from our cast rule, we can immediately eliminate some of the quadrants, okay? Right? We know that they're all not positive because we've got sine is negative. We know that cosine is positive, right? Okay. And sine is negative, so it's not going to be in this one either. Okay. And we also know that it's not going to be in the positive tangent, because if sine is negative and cosine is positive, well, tan is just sine over cos, right? So that's also going to be negative. That's one way to look at it. So we can tell now that it's going to be in quadrant 4, right? So now we need to figure out what our primary angle is. And let's draw our special triangle here. Okay, one of our special triangles is going to be the one with length 1 here, hypotenuse of 2, square root of 3. This angle is going to be pi over 3, and this one's going to be pi over 6. Okay, so from our two equations here, cosine of alpha is 1/2. We know that is cosine is just adjacent over hypotenuse, right? So that's going to be indicating that our primary angle should be pi over 3. And let's double check that with equation number 2. Is sine going to be square root of 3 over 2 for our primary angle, and it's opposite over hypotenuse, so indeed it will be. So if the primary angle is pi over 3, then we know that in quadrant number 4, it's just going to be 2 pi minus pi over 3, right? So we know that phi is going to be 2 pi minus our primary angle that we found, right? So what is this going to be? Well, we know that 2 pi with a denominator of 3 is just going to be, oh my gosh, basic math here, 6 pi over 3. So this should be 5 pi over 3, right? And then we've solved for both of our unknowns. So we know that one solution is going to be, and let's write m of x is going to be, and then our value of a we said was -2. Then we've got sine of 3x plus 5 pi over 3. And all we're doing here is plugging in our values that we found for our unknowns into the form that we were asked to present it in. See, mx equals a sine omega x plus alpha, phi We solve for a to be -2 and phi to be 5 pi over 3. So we plug that in here, plug a in as -2, and we immediately could tell omega was 3. And there you go. That's all there is to it.